Hello and welcome to Learn Digital Way. Usually, when we talk about software or tech tools, we tend to think in silos, mental boxes. You got your spreadsheet software for the accountants, your word processors for writers, your editing suites for filmmakers. Everything has its own lane, very compartmentalized. We like to categorize tools by the job title of the person who's supposed to be using them. But today, I'm looking at something that just refuses to stay in its lane. We're unpacking a single tool, one comprehensive set of development tools that has fundamentally changed not just one industry, but a whole bunch of them. It's shaping the digital world we look at every single day, and a lot of the time, we don't even realize it. And that's not hyperbole either. When you really dig further into it, the scope of this thing is actually staggering. It's really rare to find one piece of technology that's as relevant to a car mechanic's training simulation as it is to a Bollywood or Hollywood director on a film set. So let's not keep any one of you guessing. Today, we are unraveling Unreal Engine. Now, I know what some of you are probably thinking immediately. You hear Unreal Engine and your brain just goes, video games, first-person shooters, headshots, that kind of thing. And look, you wouldn't be wrong. Game development is right there at the top of the list. But here's the thing, and this is really the whole mission for today. We have to move past that assumption that this is just for video games. Because if we only look at it as a game engine, we are missing the much, much bigger picture. The applications are vast. We are talking about architectural and automotive visualization, linear film and television content generation, broadcasting and live production, and even training and simulation. That is a massive list. Going from designing a car to producing a live broadcast is a huge range. It's like saying a blender is also really good for pouring concrete. It just doesn't compute at first. It creates a bit of cognitive dissonance. Well, Unreal Engine, the world's most open and advanced real-time 3D creation tool. And to really understand why it might hold that title, and how a piece of software that was originally released in 1998, which is ancient history in tech years, the era of dial-up internet and floppy disks, a lifetime ago in this industry. To understand how something from 1998 evolved into the backbone of next-generation real-time 3D content across all these different mediums, we have to really pull apart the definition of what this thing actually is. Unreal Engine as a comprehensive set of development tools. Let's just stop on that first word, comprehensive. Why that word? Why not just call it software or a program? Because software or program implies a single function, like a hammer. You use a hammer to hit a nail. That's its job. But a comprehensive set of development tools implies an entire ecosystem. It's not just one tool, it's the whole toolbox, and probably the workbench and the garage it's sitting in. So it's not just about drawing a 3D model. If you're doing game development or automotive visualization, you aren't just drawing. You're simulating physics. How does an object fall? You're handling incredibly complex lighting. You're managing audio. You're scripting logic and behavior. Comprehensive means it handles the entire pipeline of creation, from the first sketch to the final interactive product. It's a complete environment. It's the difference between buying a set of paints and buying an entire art studio that also just happens to have a physics lab attached to it. It's the studio, the lab, and the gallery all in one package. But the phrase that really jumps out, and it appears multiple times, is real-time. It's called a real-time 3D creation tool, and it keeps referencing real-time applications and real-time 3D content. This is the absolute crux of it. You have to understand the concept of real time. This is the key differentiator. When I say real time, I just mean it's happening now, like a live phone call versus leaving a voicemail. But to really appreciate why that's so revolutionary, you have to understand the alternative. Think about traditional computer graphics. Think about the animated movies we all watched in the 90s or the early 2000s, or the special effects in big blockbuster films. Toy Story, Jurassic Park, that kind of thing. To make those incredible images, computers had to render them. The computer would take all the data, the lights, the shapes, the textures, all of it, and it would calculate pixel by pixel what the final image should look like. It's like a very, very long math problem. And for high-quality stuff, that process could take hours, sometimes days, for a single frame of video. Hours for one frame. And there are 24 frames in a single second of a movie. So you do the math. If you have a 90-minute movie and every second has 24 frames, and let's say every frame takes 10 hours to render, you're talking about massive server farms, just walls of computers crunching numbers for months on end. The workflow was you click render, you go have a coffee, maybe you go to sleep for the night, and you come back in the morning to see if it looks good. That is not real time. So when Unreal Engine is described as a real-time 3D creation tool, it means no more coffee break. The engine is calculating and drawing those images instantly, or close to instantly, usually 30, 60, or even 120 times every single second. It's all about immediacy. You move a light source in the scene, and the shadow moves with it instantly. You turn the virtual camera, and the entire perspective shifts instantly. That sounds like a video game, and that's where it all started. Games have to be real-time because the player is controlling them. You can't wait 4 hours for the screen to update after you press a button to jump. But what's so fascinating is that this real-time capability is now being applied to all these other industries that weren't traditionally real-time. And then there's another phrase, next generation. And it's not just marketing fluff. It implies a significant leap forward in quality. It suggests that the fidelity, the visual quality of what you're seeing, has reached a point where the gap between real-time, which used to look kind of blocky and fake like old video games, and offline rendering, which looked perfect but took forever, is now disappearing. That gap is closing fast. It's the convergence of those two worlds. And that is precisely why it's not just for games anymore. So let's go through the industries, because some of them are pretty surprising. Obviously, game development, that's the home turf. But then right after that, architectural and automotive visualization. Think about the old design process for a car. Historically, you drew sketches. Then maybe you built a physical clay model, a huge life-size clay model. Then maybe you'd build a full working prototype. Very expensive and incredibly slow. Now look at automotive visualization through Unreal Engine. You have a comprehensive set of tools that can render incredibly realistic lighting and materials, like the specific metallic flake in the car paint or the grain of the leather on the seats, and it does it all in real time. So the designer can put on a VR headset or just look at a big screen and literally walk around the car, change the paint from red to blue, and see it happen instantly. They can see how the sunlight hits the dashboard at 8 a.m. versus how it hits it at 6:30 p.m. They can test different interior trims. They can iterate instantly without waiting for anything. There is freedom there, greater freedom than ever before. You're not waiting for the clay to dry or a new prototype to be built. The very same logic applies to the architectural side. Instead of building a little physical model of a skyscraper or waiting days for a static, single-image render of what the lobby might look like, architects can walk their clients through the entire building before a single shovelful of dirt has been moved. And because it's real time, the client can say, hey, what if we move that wall over there? Or what would this floor look like if it was wood instead of marble? And the architect can make that change right there in the moment. It turns a presentation into a conversation, into a collaboration. It turns a static image into an experience. And remember, the goal is next-generation, real-time 3D content and experiences. A blueprint is just a document. An interactive walkthrough is an experience. Now here's where it gets really interesting. Linear film and television content generation. Linear basically means movies and TV shows, stuff you watch from start to finish. It's not interactive like a game. So why would you use a game engine? If you don't need it to be interactive, why not just stick with the old, slow rendering methods that look absolutely perfect? This represents a massive shift in how Bollywood or Hollywood and television production works. Think about flexibility. If you're a director on a set filming an actor against a giant green screen, you have no idea what the final background actually looks like. The actors don't know, the cinematographer doesn't know. You have to imagine it and just hope for the best. Fix it in post. But with Unreal Engine, because of that incredible real-time capability, you can put the digital background on a massive LED wall behind the actors. It's a technique called virtual production. The background isn't green anymore. It's the actual scene. And when a real-life camera moves, the digital background on the screen moves in perfect perspective, tricking the camera into thinking it's a real place. The visualization becomes the actual content you're filming. You aren't fixing it in post, you're seeing the final shot live on set. It brings that immediacy, that creative control back to the filmmaking process. It blurs the line between making a movie and playing a video game cutscene, but the quality is so high, you literally can't tell the difference. That is the fidelity the engine delivers. It's become so powerful, so advanced, that it can fool the eye even for the demands of linear film. Then there's broadcasting and live event production. This is one we probably see all the time and might not even realize where it's coming from. Have you watched a major election night broadcast recently, or a big sports championship? You know when the host is standing in the studio and suddenly a giant 3D bar chart representing poll results just rises out of the floor next to them? Or a hologram of a player appears next to them to show their stats? That is real-time 3D creation. That is almost certainly Unreal Engine. In a live broadcast, you have exactly one shot to get it right. You can't render it overnight. It has to happen now, perfectly synced with the live camera feeds. The engine is running live somewhere in the control room, generating those graphics and compositing them on top of the video feed instantly. It's a real-time application in what is possibly the highest stakes environment you can imagine, live television. If the engine crashes, the graphic just disappears off the air. The fact that major broadcasters trust it for live production speaks volumes about its stability and its power. And then the last application on the list, which sounds a bit more serious, training and simulation. This is where we completely leave the world of entertainment and enter the world of pure utility. If you're training a pilot or a surgeon or maybe a heavy machinery operator, you need a safe environment for them to practice in. But for the training to be effective, it has to be incredibly realistic. If the simulation doesn't behave like the real world, the training is pretty useless. And worse than useless, it could be dangerous. So they use Unreal Engine to build a virtual cockpit for a new airplane, or a virtual operating room, a whole virtual world. Because the engine is that comprehensive set of tools, it can simulate not just the look, but the physics of wind shear, the specific lighting of a runway at night, the mechanical resistance of a control lever. And it does it all with fidelity. By the way, if this is actually helping you understand a bit better, hit like and subscribe if you want to keep building along with the series. So, getting back, fidelity here isn't just about making it look pretty for a movie. It's about making it accurate enough for someone to learn a critical skill from. If the visual fidelity is off, it breaks the immersion, and the person's brain doesn't buy into it. If you're training for a dangerous emergency situation, you need to feel on a primal level like you are there. Unreal Engine provides that next-generation level of realism that makes the brain believe, okay, this is happening. I need to react. It's just amazing how one set of tools can stretch to cover Hollywood or Bollywood blockbusters, car manufacturing, live sports broadcasts, and life or death flight simulation. It really is the definition of flexibility. Which brings us to the core promise. The engine enables creators to work with greater freedom, fidelity, and flexibility than ever before. The 3 Fs. Let's start with fidelity. Ultimately, the ceiling is reality itself. Fidelity refers to the accuracy of the representation. High-fidelity audio sounds just like the real musical performance. High-fidelity 3D content looks indistinguishable from a photograph or a live-action video. And doing that in real time is the really, really hard part. That is the magic trick. Anyone can paint a photorealistic picture if they have a year to do it. But to do it at 60 frames per second, that requires unbelievably advanced technology. It's calculating in real time how every ray of light bounces off every surface, how shadows soften over distance, how fog realistically obscures your vision. All of these incredibly complex things, all happening instantly. Freedom, in a creative context, usually refers to the removal of technical barriers. In the old days of 3D creation, you were constantly fighting with the computer. You'd have a vision. You'd say, I want to put a dense, lush forest here. And the computer would basically say, nope, I can't handle that many trees. The system will crash if you try. So you always had to compromise. You had to find clever ways to fake it, to trick the viewer. Freedom implies that the tools have become so powerful, so optimized, that the creator can just create. If your vision calls for a forest, you plant a forest. If you want a sprawling city, you build a city. The tool enables your vision rather than restricting it. A good, comprehensive set of tools shouldn't feel like a hurdle you have to overcome. It should feel like a direct extension of your imagination. And then flexibility. We've sort of already proven this one with that long list of industries. A tool that works just as well for a game developer as it does for a filmmaker or an architect is the absolute definition of flexible. It means the underlying technology, the code that runs the engine, is versatile enough to handle a stylized cartoon platformer 1 minute and a photorealistic architectural walkthrough the next, without needing to be fundamentally rewritten for each task. It adapts to the user and to the output. Whether you're trying to display your creation on a movie screen, a VR headset, a live TV broadcast, or a game console, the engine can handle it. Now, there's another claim that I find really intriguing. It's called the world's most open real-time 3D creation tool. Open is a very specific and very important choice of word. Usually when we talk about this kind of high-end professional software, it's expensive, it's locked down, it's totally proprietary. But open, in the software world, implies a high degree of accessibility. It means it plays well with other tools. It's not a walled garden. You can import 3D models you made in another program, bring in audio files, write your own custom code to make the engine do something new and specific to your project. Epic Games, who are the creators, apparently allow users to look under the hood and even change the engine itself, which is pretty rare for something this advanced. Very often companies want to hide their secrets and keep it all proprietary. But the point is made that it's the world's most open. This suggests a core philosophy of sharing the technology, of empowering users rather than hoarding it. And that philosophy can be traced right back to the very beginning, to the origin story. Epic Games released the original Unreal Engine in 1998. Let's just pause and appreciate that. 1998, the internet was barely a thing for most people. 3D gaming was really in its infancy, and here comes this engine. It was a pivotal moment in gaming history, and it became so popular for a very specific reason. It wasn't just because the graphics were good for the time, although they were. It became popular with the community because it made modding quite easy and accessible. For anyone who might not be a gamer, Modding is just short for modifying. In the simplest terms, it means taking the game that the developers officially released, opening up its files, and changing them to create something new. Sometimes that's like digital graffiti. But often it's much more sophisticated. It's about creating brand new levels, changing the fundamental rules of how the game is played, swapping out the characters to look like your friends or famous movie stars, and in some cases, creating entirely new games inside the original game's engine. And the key thing is that Unreal Engine made this quite easy and accessible. Before Unreal Engine, most game engines were these impenetrable black boxes. You played what you were given, and that was it. But Epic Games, back in 1998, made the radical decision to give the community the keys to the castle. They literally included the level editor, the actual powerful tool they themselves use to build the game. That's like a car company selling you a car and including the entire factory toolkit in the trunk. Just, here's our finished product, and here are the tools we use to make it. Have fun. It was revolutionary, and it birthed an entire generation of creators. Think about the game developers and creators across industries working today. I would bet a huge number of those people got their start as teenagers in 1998 or 1999, messing around with the Unreal editor and modding their favorite game in their bedroom. That openness, it's literally in the DNA of this thing. They realized very early on that if you make your tools accessible, your community will build things you never even dreamed of. They'll push the technology in new directions. And that grassroots support led to massive popularity. It built a huge, loyal user base of people who knew the tools inside and out. So when those users grew up and went into professional fields like architecture or film or automotive design, guess what tool they already knew and wanted to use? Unreal Engine. The modding culture of 1998 directly laid the groundwork for the cross-industry dominance we see today. From kids tinkering with game levels in their spare time to professionals designing next-generation real-time 3D content for some of the biggest industries in the world. It's a remarkable story of technological and cultural evolution. So let's bring it all together and look at where we are now. What we're really seeing is a democratization of high-end creation. It's described as a comprehensive set of tools for everyone, from the indie game dev to the Bollywood or Hollywood filmmaker to the car designer. It doesn't imply there's an elite version for the big studios and a watered-down version for the little guys. One single powerful engine. The kid in their bedroom making a mod today has access to essentially the same level of fidelity and power as a major studio making a blockbuster movie. That is the implication of being the world's most open tool. It levels the playing field in an unprecedented way. It means the barrier to entry for creating high-end 3D content isn't access to technology anymore. The technology is there. The comprehensive set of tools is available to pretty much anyone. The main barrier is just creativity and skill, not access to the tools themselves. And that is a huge, huge shift from the past, where you needed $1 million workstation and proprietary software just to do a fraction of what this engine can now do on a consumer-grade PC. It enables creators across industries to speak the same visual language. An automotive engineer's 3D car data can be used in the TV commercial for that car, which can be used in the video game featuring that car, which can be used in the movie that has a car chase. It's all the same real-time 3D content, all connected, a unified pipeline. It's the convergence of all visual media being powered by one incredibly advanced engine. And what does this mean for the rest of us, those who aren't 3D artists or game developers? It means we're absolutely surrounded by it, whether we know it or not. When you watch that new big-budget sci-fi show on your streaming service, you are very likely looking at environments and effects made in Unreal Engine. When you go to a website to configure your new car, that interactive 3D model, that's likely Unreal Engine. When you watch election results and see those fancy graphics, that's Unreal Engine. It's the invisible layer of real-time visual magic being draped over more and more of our digital lives. It's the engine of the virtual world. And it's only going to become more prevalent. As the fidelity continues to improve, the line between what's real and what's a simulation will blur even further, which is both exciting and, I have to admit, a little bit terrifying. But mostly, it's incredibly exciting for creators. The freedom to create whatever you can imagine and see it instantly is a profoundly powerful thing. So to wrap up, let's just recap the journey. We started with the definition, a comprehensive set of development tools, not just for making games, but for this entire spectrum of industries: architecture, automotive, film, live broadcast, training, and simulation. All of it is powered by that core concept of real time, the ability to create and change next-generation 3D content instantly without having to wait for those long, slow renders. This power is driven by three pillars: fidelity, meaning it looks real; freedom, meaning there are fewer technical limits holding you back; and flexibility, meaning it works for almost any industry or output you can think of. And it's all grounded in a history of being open, starting with that pivotal release back in 1998 that embraced the modding community and evolved into a tool that invites creators of all types to participate and innovate. It really is the world's most open and advanced real-time 3D creation tool, and it has come such a long way from just shooting monsters in a dark corridor back in 1998. It has become a foundational tool for building the modern visual world. And here's a final thought I want to leave you with. This engine started by letting gamers mod their games, making small changes, being creative in their own way, and now it's this massive professional tool used by all these major industries. The evolution from hobbyist tool to industry standard. But its DNA hasn't changed. It is still open. It is still about freedom and accessibility. So if these tools are only becoming more powerful, more realistic in their fidelity, and arguably easier to use all the time, are we moving toward a future where everyone is a 3D content creator? Are we blurring the line not just between reality and simulation, but between consuming media and actually building it? If the tools to make a movie or a game or a virtual world are sitting right there on your computer, accessible and open, what stops any of us from building our own worlds? Maybe nothing. Maybe the next great architect or filmmaker isn't in a fancy studio right now. Maybe they're at home, in their bedroom, just modding reality. It's a brave new real-time rendered world out there. What do you think? Let me know in the comments below. Thanks for listening and watching, everyone. I will catch you next time.